When we use inheritance in a coding language like Python, one of the great ways that we can utilize this idea of borrowed code functionality is by creating a more generic parent class that more specialized child classes implement. This is easiest to understand with some examples. I'm going to create a vehicle class. And this class is going to have a initialization method that I'm going to set a couple of parameters in. I'm going to say self.numWheels and self.numPassengers. So each vehicle that we create will have a certain number of wheels and passengers defined as a value, a variable parameter inside of it. And I'm going to allow these to be sent in when this is instantiated. So I want to actually get the program to decide right from the start what these values are. So I'm going to allow this initialization function to actually accept these two parameters and then assign it to the instance variables. Awesome. Now, here's the thing. If I created a vehicle, what would I send in for these values? For number of wheels or number of passengers, because there's lots of different types of vehicles, and I'm not sure kind of which one I want. So technically, what I could do is say, like, maybe I just define it as a car. I give it that name, and then I say, okay, a car has 4 wheels and generally fits 5 passengers. So I give it that kind of initial state, and then I can work with this car. Very cool. But that works just fine if I have a car and maybe another thing, I don't know, maybe like a motorcycle. It's also a vehicle, and in this case, it has 2 wheels and generally just fits a single passenger, at least this one that I'm making. So I'm able to have some differences that work just fine with this type of conceptual organization in a single class. But what if I wanted to create some kind of unique things that each one of these specific things were able to do? For example, what if I wanted the car to be able to honk its horn? That's maybe not something that I want a motorcycle to be able to do. And maybe a motorcycle, I want it to be able to, I don't know, lean amount. Define or max lean amount. So define how far I can lean over before I might like lose traction on the wheels or something. This doesn't really make sense to apply to a car. So where am I going to get these behaviors? And where am I going to add these into my code? In the vehicle class, it's kind of a weird spot because it doesn't really apply to either of these things generically. Here's where the inheritance comes into play. I'm going to define a class for a car and allow it to inherit from my vehicle class. I'm also going to define a class for my motorcycle and allow it to also inherit from my vehicle class. And in each of these classes, I'm going to define an initialization method that borrows from the initialization method of its parent. Let me just get this set up here really quick. Now, because I'm initializing my parent's initializer, I need to send it the information that it's looking for. And so I need to think about a car. Does it have any generic rules that would fit nicely into this, or is it something that I need to kind of define with a user input? And here, for a car, technically it can have alternatives to this, but most cars have 4 wheels. So I'm just going to allow every car that's made to come pre-packaged with 4 for the num wheels variable. And the num passengers is generally 5. But I could, if I wanted to, actually allow my car to kind of have a specified num passengers when I create it, and then pass that value along to the parent when I initialize it. Just in case I have a car that maybe has less or more seats, I have some flexibility built in. So all my cars will always have 4 wheels, but a variable number of passengers. From a motorcycle, in this case, there's going to be 2 wheels, and technically, we'll just say 1 passenger to keep it simple for now. So now, down here, let's back this up a little bit. When I make a car, I don't want to make a vehicle. I want to make a car directly. And when I make a car, I have to tell it the number of passengers. And this car is going to allow for 5, maybe kind of a normal car. And my motorcycle, rather than being built from the vehicle class directly, is going to be built by the child class motorcycle. I don't need any parameters because the motorcycles have these kind of predefined. So now I have a car and a motorcycle that actually have these parameters inside of them. They have a number of passengers and a number of wheels. Same with the motorcycle, a number of passengers and a number of wheels. And if I wanted to know a little bit more about this, let's just say the number of wheels, and I have it print out for the car, and I have it print out for the motorcycle, the number for each of these things. In my runner, I see the car has 4 and the motorcycle has 2. The management of actually assigning these variables was dealt with in the parent class, and I just passed the information along in the inheriting classes. Now, this so far it might not seem super helpful because there's a lot of extra code just to kind of save repeating these 2 lines a couple times. So far, maybe not super worth it. But what about if I now go and add some other functionality that all vehicles might have? For example, maybe I define a method called drive. And what will this method do? Well, I'm not too sure exactly in this example, but what if for now I just print out I'm now driving? And maybe I'll use my quotations because I just realized I have I'm in there. I'm now driving. And so maybe I could actually create some variables for gas levels and adjust them, make some big algorithm. For now, I'm just going to keep it simple. Now that I've made the drive method in the vehicle class, I've made this method a single time, but if I come down here and I go car.drive and motorcycle.drive, I see that both of these classes now have the capability of driving. Because the parent class has it, both of these child classes inherit that behavior. I only have to add it in this one place, and that addition echoes into the child classes as well, and they both have shared behaviors. Maybe I even want the ability to say def change num passengers. Maybe I have adjustable seats, and I want, or maybe I have like different rules for this game that I'm making that allows different passengers at different times. And I just allow a new max to be passed in as a parameter. I can now set the value of my num passengers to be equal to this new max value. Because I've added this in the parent class, it means that both my car change num passengers. Maybe I'm taking out the middle seat in the back, and the motorcycle, I'm not racing with it right now, so maybe I allow there to be 2 passengers instead of 1. And because I initially said there was only 1 allowed. So I have access to this shared behavior defined in the parent class. One more thing that I can do, though, is I still have the ability to add specialized behaviors or even instance variables to the inheriting classes that are unique to that. So, for example, maybe in this car, I said before, I want the ability to honk my horn. And in this, it's just going to print out a message that goes, honk, honk. This is something I only want the car to be able to do. And by building it in the car subclass, I have the ability to honk my horn with the car, but my motorcycle, notice there's no autocomplete here. There is no honk horn method in the motorcycle. It's not relevant for that class. Likewise, in the motorcycle, what did I say? I don't remember even what I said earlier. I want the motorcycle to be able to, max lean amount. I want to actually be able to set a value for the max lean, and then maybe the motorcycle actually has a variable called lean amount that it has kind of initially set to some value. Maybe I'll just say it's 60 for the number of degrees. But in here, the self lean amount equals the max lean that I pass in. This motorcycle not only has a custom behavior, but it has this lean amount. Oh, I meant to go motorcycle. Motorcycle has the lean amount variable, but it also has the set, what did I do? Change. Oh, the max lean amount is what I typed it as. There we go. The method. It has both of these that the car does not. If I type in lean amount car dot, can't type right now, lean amount or max lean amount, it doesn't exist. These are unique properties and behaviors that only the motorcycle has, the car doesn't. So what does this inheritance strategy allow us to do? Create a generic parent class that has all of the shared attributes and behaviors I want for this type of thing, and then the children that inherit from it get to access from one common point all of the attributes and behaviors that are shared. You can even initialize their values in your initialization method, but they also still have the flexibility of implementing their own custom behaviors and parameters or values whenever you need to. So you have this ability to borrow as well as still be unique and customized. And we use this type of object-oriented design principle all the time in creating different layers of hierarchies in our code. And in our project for this week of our work, we're going to see that in action as we create a bit of a game storytelling experience that involves all that we've been learning, as well as a bit of an exploration of how we can use inheritance to just make everything a bit more organized and sophisticated.